Okay, guys, so this is section 15.2, multiplication and division of rational expression. So first, what we're going to do, we're going to start talking about multiplication of rational expression. Okay, so how are you going to multiply rational expressions? You multiply them like fractions, which means you multiply numerators together and denominators together, and then you're trying to cancel repeating factors. So definition is if you have rational expression p over q and you multiply that by different rational expression, which is r over s, you multiply numerators together and you will multiply denominators together. Okay, so that's what we're going to do. Again, in this case, p, q, r, s are polynomials. And since they are rational expression, q can't be 0, s can't be 0. Okay, so let me write the steps. Of how to multiply rational expressions. And we'll move on to the examples. So first what you're going to do, which will be step 1, you will need to factor both numerator and denominator. We spend so much time on factoring because we are always going to use it. Step 2 will be cancel repeating factors. So how are you going to cancel repeating factors? If you have the same factors on the top and on the bottom, you can just cancel. If they repeat on the top and on the bottom. Okay, and the last step will be multiply the remaining factors. In the numerator and multiply the remaining factors in the denominator. Okay, so 3 steps. So let's start with the examples. Example 1, multiply. Okay, the first one will be 7a divide, you can say divide, 7a over 3b times 15b over 14a squared. Okay, so what I'm going to do, I'm trying to factor each of my rational expression. So 7a, I cannot factor, okay? Over 3b, I cannot factor this one, times 15b, I can rewrite that as 3 times b, 3 times 5 times b, and 14a squared, I can rewrite that as 2 times 7, and a squared is the same as a times a. So now what we have, I rewrite each expression using factors, and now I'm ready to cancel since I have a multiplication. So how you cancel? The expression which repeats on the top and on the bottom, you can just cross it out. So I have 7, that cancel. I have a, that cancel. I have 3 on the top, 3 on the bottom, cross them out. Then you have b on the top, b on the bottom, cross them out. So we cancel repeating factors, and now we're just rewriting with the remaining factors. So in my numerator, after canceling, I only have 5. In your denominator, we only have 2 times a. So the answer will be 5 over 2a. Okay, so that was a nice example, and we're slowly going to build more advanced examples. So let's move on to example B. We have 4x minus 8 over x plus 6 times x squared plus 6x over 2x. So again, I really don't want you to multiply them together. Just make sure that you follow the steps. Step number 1, factor both numerator and denominator. So you need to factor each expression if it's possible to factor. So I'm going to start with 4x minus 8. Okay, so 4x minus 8, let's factor. Here you have greatest common factor, which is 4. So we're going to factor 4. And again, in the parentheses, we'll have x minus 2. Okay, so what I'm going to do, to not forget anything, I'm going to rewrite that 4x minus 8 as 4 times x minus 2. Okay, next. Next, I have x plus 6. So x plus 6 is prime. Prime means you cannot factor. Okay, so I'm going to rewrite it. So keep it as x plus 6. Times. Next, what I have x squared plus 6x. So let me factor. X squared plus 6x. So the greatest common factor here is x. So again, variable to the lowest exponent. So we're factoring x out. And again, I'm just quickly reviewing what we already know. Take your original expression, which is x squared, and divide by the GCF, which is x, and we end up with x. So that's what we have in the parenthesis. Take the second original expression, which is 6x, divide by GCF, which is x. You end up with 6. That's what goes inside of the parenthesis. So we're going to rewrite x squared plus 6x as x times x plus 6. Okay, so I'm going back to my original. X squared plus 6x, we're going to rewrite as x times x plus 6 over, and then you have 2x. Again, 2x, it's prime also. We cannot factor. 2x is prime. Okay, there's no GCF between 2 and x, so we're going to keep it. Like you see, what we have here now, we rewrite original expression, rational expression times rational expression using all the factors. Now I'm going to look what I can cancel. You can always cancel the repeating expression, which they repeat on the top and on the bottom. So I have x minus 2, I cannot cancel. I have 4 and 2. So 4 is the same as 2 times 2, so they will cancel. Here I will end up with 2. Then I have x plus 6. It's on the top, and x plus 6 is on the bottom. So you can cross them out. And we can also cancel x. X is on the top, x is on the bottom, and that's it. So our final solution will be 2 times x minus 2. So that's our answer. Okay. Next one, we're going to do something with quadratic. Since we learned how to factor quadratic equations, so let's practice. See, we have p squared plus 4p plus 3 over 5p plus 10 times p squared minus p minus 6 over 9 minus p squared. So again, we follow the steps. Okay, step number 1, factor both numerator and denominator. Okay, so here we have a lot. Okay, so first let me start with factoring p squared plus 4p plus 3. This is quadratic, so factor using AC method. And this is easy AC method because A, which is the leading coefficient, which is in front of p squared, is equal 1. B, it's equal 4. C, it's equal 3. So we multiply A times C. We're getting 1 times 3, which is 3. Then we're looking for two integers, which by multiplication give us AC, which is 3. And the same two integers, which by addition will give you B, which in our case it's 4. So we need to check what's going to work. 1 and 3 definitely will work. And now when you find those integers, so we're going to rewrite that p squared plus 4p plus 3 as p plus 1 times p plus 3. And again, we don't need to worry about finding GCF because like you see, the leading coefficient A was equal 1. So that's that easy case. Okay, so I'm going back to our problem. And I'm going to rewrite p squared plus 4p plus 3 as p plus 1 times p plus 3. Okay. Next, what I'm going to do, I'm going to factor 5p plus 10. So factor 5p plus 10, the greatest common factor, it's 5. So we're going to factor 5 out, and you're getting 5p divided by 5, which will give you p, plus 10 divided by 5 will give you 2. So we'll go back, and we will rewrite 5p plus 10 as 5 times p plus 2. Just put that correctly, that p over there. P plus 1. Okay. Next, what I'm going to do, I'm moving to the second rational expression, and I'm going to factor p squared minus p plus 1. Okay, so let me just do that on this side. So here, factor, let's just separate them right here. So p squared minus p minus 6 factor, the same thing using AC method. So a, it's a coefficient in front of p squared, which is 1. B, it's a coefficient in front of p, which is negative 1. C is a number which is by itself, which is negative 6. Again, this is easy case because that leading coefficient is 1. Okay, so that's the fast case. So step number 1, we multiply a times c. We're getting 1 times negative 6, which is negative 6. Find two integers, which will give you AC, which is negative 6 in our case, and find two integers, which sum will give you B, which is negative 1. So what's going to work? Negative 3 and 2 will work. Negative 3 times 2, it's negative 6. Negative 3 plus 2 will give you negative 1. So now, p squared minus p minus 6, rewrite using factors, which will be p minus 3 times p plus 2. Okay, so I'm going back to our problem. So now we are right here, times, and again, p squared minus p minus 6 is the same as p minus 3 times p plus 2. Okay, and one more. Last thing what we're going to do, we're going to factor 9 minus p squared. Okay, so factor 9 minus p squared. So what I recommended, before you guys will do it, why don't you factor negative 1 first? So we can switch the order. So if you factor negative 1 first, you will end up with negative 9 plus p squared, which you can rewrite as negative 1 times p squared minus 9. Okay. So what I want you to do, hopefully you guys remember the formula, a squared minus b squared formula, which is the difference of two squares. This is the same as a minus b times a plus b. So we have that here, okay? P squared minus 9, so let me copy that negative 1. But p squared minus 9, you can rewrite as p to a second power minus 3 to a second power. And now we can factor that p squared minus 3 to a second power using the formula a minus b times a plus b. So in our case would be p minus 3 times p plus 3. Okay. So I quickly want to explain it one more time why you see negative 1 right here. Since, again, in the parentheses which we are already building, because the idea is to get factors and cancel them. The first expression is p. So what I was trying to do, I was trying to switch the order. Okay, so we have p in front of 9. So what I did first, I factored -1. So again, so then 9 changed to -9, negative p squared become positive p squared. I switched the order, so we end up with p squared minus 9, and then I was able to use the difference of two squares formula. Okay, that's the formula. We call it difference of two squares. And I was able to factor that as p minus 3 times p plus 3. And of course, I need to keep that -1. So let's go back. So here we have -1. Wait, that was in purple. Okay. So that 9 minus p squared, after doing all that work, we end up with -1 times p minus 3 times p plus 3. So finally, we have it. Okay, so let's look right here. Okay, we have multiplication of two rational expressions. Everything is in factors. So now I'm ready to cancel. Cross the factors which repeats on the top and on the bottom. So p plus 1, okay, it's only on the top, so we're keeping. P plus 3 on the top, but also you have on the bottom, so cross them out. Now I'm moving to p minus 3. It's on the top, but also it's on the bottom, so we're ready to cancel. And then you have p plus 2. It's on the top, but also it's on the bottom, so we're ready to cancel. So now our final solution, we're just going to rewrite the factors which are staying, which is p plus 1 in numerator. In denominator, we only have 5 times -1. So the final solution is p plus 1 over -5. So this is correct solution. I don't have any issue with that, but usually when negative, it's in denominator. What they doing with that negative, they take that negative from denominator and they put it right like in the middle of the fraction. And you just rewrite that as p plus 1 over 5. Okay, and this is the answer which you will see most often. Again, there is no issue with p plus 1 divided by -5, but again, this is something what we see more often in mathematics. Okay, next one will be division. Let me see how long is that video. I think I can continue. Okay, let's see how much. You know what, guys? I will split this into two videos. So I will stop here, and the next video from section 5.2 will explain the steps of how to divide rational expression.